This video is produced for those students enrolled in the Diesel Engineering 2 simulation course held at Cal Maritime. This video will cover all the operational procedures required to successfully complete Lesson 5. To set the stage, we have an ultra-large crude carrier that has just finished a shipyard period. It has no cargo on board and is unballasted. There is currently 2 generators in service. All the pre-departure checks have been completed by the engine crew, and the engine has been being turned over on the jacking gear for at least 30 minutes. The bridge has given down notification that the vessel will be getting underway shortly. It's going to be a fairly short maneuvering. Kind of to illustrate this, I've put up the HHI industry shipyard in Ulsan, which is one of the largest, if not the largest shipyard in the world. And so kind of you can imagine you're at one of the berths and you can see 2 vessels in the background, and you can also see the harbor entrance. So with this, it's simply a matter of turning the ship around and heading out, and you could get departure in around 30 minutes with this type of a situation. So that's kind of how you can picture all of this. One thing of note is that I was not able to run the virtual reality portion of the Kongsberg simulator for this discussion. The reason being is that my office laptop computer does not have the speed necessary to run the Kongsberg virtual reality simulation, plus this PowerPoint that I use, plus also the video capture, and it became non-responsive. So I'm having to do that just using the process directories and panel directories and not being able to do the virtual. Virtually having the students operate the engine at the engine side is very important in my estimation. I think that's an important skill to learn, and your simulation instructor will go over this procedures with you in class. So that's just a limitation of my system. All right. Briefly, with the engine side, the virtual reality, this is a picture of it. On the left is the Kongsberg simulator, a page capture. And then on the right is the actual cabinet that is, this drawing comes right out of the Burmeister Wain manuals. And it runs exactly what you would see on the actual vessel fitted with the MC Burmeister Wain. The reason it's kind of important for me that you see this is realize that this is an emergency procedure. You typically would not run the engine at the engine side. Most vessels are going to maneuver on bridge control, or the engineers are going to be maneuvering, do it at the engine side. So many companies will actually practice with the engineers, new engineers, how to run this engine side controls briefly so that you are familiar with it, because the worst possible situation is to have to go to the engine side control if you in an emergency when you have never actually accomplished it before. Now on the changeover, there is important too that you have to specifically mechanically disconnect the hand wheel. There is a wheel on the front of this local control, and when you turn that wheel, you are actually moving the rack assembly. There's no interface. You are mechanically moving the rack. Well, as part of the changeover process, you have to disconnect that manual connection and switch it so that the governor will control the rack. After that is accomplished, then you physically have to move a pneumatic switch that will transfer the pneumatic controls to EOS. So the instructions from Burmeister Wayne are actually part of the Kongsberg simulator, and in this lower left where I'm kind of circling, if you click on that, that will give you the instructions on how to do this. And the mechanical part of this is done using this wheel on the side. On here, there is a switch that's going from emergency to remote. And this wheel, basically what it does, will be done for you in class. By moving this wheel back and forth, it is shifting so that that wheel is mechanically connected to the interlock, or excuse me, to your rack, or the governor is. And it's simply a matter of turning this hand wheel, and then when you're completed flipping this pawl in. Again, that will be discussed in class. All right. Now, one of the first things we're going to do is put heat on the separation tank from the OWS. It's important to note that we will not be using the OWS in this exercise. Under modern regulations, the vessel needs to be underway in proceeding to another port, and it needs to be outside of restricted zones, which is usually at least 15 miles offshore. So you would typically not be pumping over the side for at least an hour after departure, and we physically don't have that time to do that within this scenario. We will put the heat on the separation tank because that takes time to heat that tank up, and you would want it available for when the bridge to call down and clear the engine room to start pumping bilge water through the OWS overboard. So all you have to do is put power on the electric heater. And as you go through these steps, always take the time to make sure that you actually see the response. In other words, here you could see that it's 21.6 kW are now flowing to that electric heater. From there, we're going to go over to the shaft generator. And on the shaft generator, it has an air clutch, and you put the air on the clutch, shift it into local, and then connect it. Watch to make sure that the two plates come together, and you'll have a clutch in light come on, and then hit remote. Now, well, at this point, I'll also put the auxiliary power on. And you have to wait until you see a running light. You'll see the power come up here and a running light come up here. And then you can start the synchronous condenser. As soon as you hit the start button, you'll see RPMs coming up here. If you go to the panel directory and go to shaft generator, you'll see the run light flashing, which tells you that that synchronous condenser is in the process of coming up and being available. Go ahead and for the shaft generator, set your excitation about 50%. I know from experience that that will get you in close to being 440 volts. Now let's go back for a second. Very briefly, this is a shaft generator that's being run off the main shaft through a tunnel gearbox. So it is going to run at an actual RPM higher than the main engine. In this, the AC output of the generator is converted from AC, in what they're calling a static inverter here, it's rectification, from AC to DC, no frequency component. And then electronically, it is going through an inverter that will use modern power electronics to convert DC power into 440 volts, 60 hertz, three-phase. And then that is fed out of the shaft generator, and any other generator can be connected up to that, and they'll play very well. The synchronous condenser, you can see it runs at 1800 RPM. That is a synchronous motor that is being used for power factor correction. So in other words, it's just a synchronous motor. It's not driving a load, and it's just sitting there spinning. And what it does is its excitation automatically is raised or lowered, and by doing that it will create kVAR and shift, most likely most ships are about 0.8 power factor, shift it from 0.8 power factor to 1. All right, so that done, let's go over to local control, and we are going to take the jacking gear, stop the motor, disengage it, and go ahead and put this in auto. And then we're going to be waiting for the captain to give us permission to roll the main engine over on air. So we've gotten permission to roll this over on air. Now realize you would never do this without the captain's permission. Typically the captain will have a tug alongside with lines tied to the engine, or to the vessel, I'm sorry, because 30 RPM is about what you're going to hit when you do this test, and that will surge the vessel alongside the dock. So the bridge and the deck department have to be prepared for this and prepared for that surge. So you have to wait for the captain's instructions. What we're going to do is we're going to go to the start air system. We're going to open the supply from the second bottle. Most captains are going to require that they have the availability of both of these bottles on the line because that will give them more starts. We're going to put air to the main engine, and then we are going to go to the maneuvering page, and you have to open these 3 block valves. These block valves are a lockout tagout that would prevent, pneumatically, the control system, prevent the engine from starting. And then we're going to go to local control, and with the rack setting at 0, we are going to first roll it in the ahead position. So I'm going to hit the start button, and you're going to watch for this middle gauge, which is your RPM, to move clockwise. Clockwise is ahead, counterclockwise is astern. So let's go ahead and try it. You hold the button down until you see the RPMs come up, and as soon as you see them come up, you release. And then it will come back down again. Wait till it gets to stop. One thing, by the way, too, you should be using the closed circuit TV, just panel directory, the CCTV monitor on your second monitor. You should have that on the main engine, and you'll see each of the cylinders clearing through the indicator cock. All right, now I'm going to go, I rolled it ahead. Now I'm going to roll it astern. Make sure that it doesn't go ahead again. You got to make sure that it goes in the astern position. Now, this is one of the major things. You know, you're not blowing it down really to remove water. Whoop, see there it went ahead. So I released, it's reversed. All right, so it did come up in the reversed and we cleared it. But that's one of the things that you're testing here, is the fact that this engine will roll over in the head direction and the astern direction. And I'm going to try it one more time astern just to make sure that it is going astern properly. And it is. Okay, now we have gotten a notification. The captain has observed the air rolling in both directions and is satisfied with the fuel off process. So no fuel, we're rolling it over on air. So what we're going to be doing now is go ahead, we can close our indicator cocks. So go to each of the cylinders, close your indicator cock. And then the next thing we're going to do is we're going to look at ventilation. We've got a slight vacuum, nothing bad, but I'm going to pressurize the engine slightly by putting on both supply fans to make sure that this engine has enough air when it starts. Okay, now the bridge is requesting standby at this time. So we're going to do that. Unfortunately, you can do it both on the same page on the virtual, but on this we have to go to the local to clear the stop, and then we have to go to panel directory, main engine control, to get the standby, and then we'll go back to local again. Now I've got a stop bell. I'm ready to maneuver, so I can go ahead and move my rack to a starting position, which is about 30%. Now we've got a dead slow. Below the stop is astern, above is ahead, so we're going to be going astern, and all I have to do now is hit the start button, watch for the engine speed to come up and release. Now the engine can stop, but it just picked up, and it is coming in at about 30 RPM. If it's more than that, then you need to back off on your rack setting a little bit. Most likely if it's below that, the engine will stop. It doesn't run at lower than 30 RPM. Now, to actually stop the engine, all I have to do is hit the stop button. That stop button, what it does is it activates the puncture valves and stops fuel delivery of all pumps to the engine. All right, we're getting a dead slow ahead. Make sure that I switch to the ahead position, and when I go to start this, I want to make sure it's moving clockwise. And it did, so I released it. The RPM is caught. The engine may need a little bit more. Let's try 32. It's not at the, I'm getting a stop, so I'm going to go ahead and stop. At this point, I'm going to actually stop the engine. The other way to do it is shut the rack down, and I will also hold the stop button. Okay. The engine is requesting that maneuvering responsibility be switched to bridge control at this time. Of note, you will not be able to switch over if this from local to EOS if this rack is not at 0. It has to be at 0 to do the changeover. And then we're going to go to maneuvering system and switch it to remote on this page. And then we will check to make sure that that occurred by going over to the control and making sure where it says right here on the governor, make sure that it is switched from local to remote. And make sure that that is engaged. And again, if you don't have the rack at 0, it won't. Now we're going to go to back to main engine control. The bridge is requesting bridge control, so we just gave it to them. They've confirmed they have control of the engines. The captain is asking for bow thruster. So all we do here is we go to panel directory, generator control, put this in alert mode, and then we're going to go to starters and go ahead and close the bow thruster circuit breaker. So they have power on it now. Now they will actually, this course control, they will actually start the bow thruster and control the thrust automatically from the bridge. So we're going to go to our generators. Let's bring up the power load diagram, and I'm going to put this kind of down here out of the way. Right now, diesel generator 1 and the turbo generator actually on the line, the steam turbine. What happens now, you're seeing the uptick. That is because they just started the bow thruster. This diesel generator number 1, if the power comes up to where this gets into this red zone, that's its point that it would automatically start. You see another generator. So another generator is required. It is started number 2, and they will automatically connect it up. So this is your power management system. It saw an increase of load required, and it automatically puts the generator on the line. It's connected, or it's connecting now, I'm sorry. So now we'll have 3 generators on the line, and it's going to balance the load between them. Alert mode. Alert mode, what that is tells the power management system not to take off any generators off the line. In other words, this same diagram, if the load was to drop down into the green on these generators, then it would normally, that's its low load point, it would normally take one of these 3 generators off. It won't do that in this case because you have instructed it not to. And as far as your standing orders, the chief engineer, as part of the standing orders, wants all 3 generators to be in service during the entire maneuvering mode. One of the things to think about, diesel generator number 1 is burning clean distillate. Number 2 is burning heavy fuel oil off of the main fuel system, the same system that supplies fuel to the main engine. The turbo generator is being supplied steam from the oil-fired boiler, which is burning heavy fuel oil on its own fuel circuit. So all 3 of these generators are being supplied fuel from a separate source, so that if any one of them drops off the line for whatever reason, then the other 2 can pick it up. In other words, like if you had both of the generators on heavy fuel oil and the viscosity went out of spec, then you could have both diesel generator number 1 and number 2 fail at the same time. So it just increases your options. All right, so what do you watch when they are maneuvering? Main engine control is, you can see right now that they have set in astern. All you see from the engine room, the same thing in the full mission, is what the bridge orders are is on this strip gauge beside the throttle, the kind of white arrow they're showing, that's your position. The black is the bridge position. So we are going astern at 38 RPM is the RPM command. So if we look down 38 RPM, we are now doing half astern. Very helpful, and what I tend to watch is this indicator panel. Now, some of the things that are important on here, one is it's showing rudder position, and it's showing that we're hard over on the rudder. That dramatically increases, well, not dramatically, but that increases the load on this engine. Having that rudder 30 degrees over puts a lot of drag on the vessel and increases the load on the engine. Now, one of the things we just saw, that the main prop, it just stopped. So when it's stopped, you want to go to your control system. Now, these are the permissives for engine start. Right now we are on bridge control. The bridge has a stop order issued. The cam position is in astern. The puncture valves, fuel off here, that is that puncture valve signal is activated, shutting off fuel, and the engine is not rotating. Now, some of the things above this, above reversing level, if the ship is moving more than about 6 knots through the water, the speed of the vessel and the flow of the water going over the propeller will keep the engine turning even though the fuel is shut off. So if you're above 6 knots, that main engine is spinning. Then what happens is, okay, we just came off the stop. We've got a start initiated, and you can also see it here. It went from starting air to waiting for ignition, and the engine started. That's one of the things what you want to be watching these for. You're waiting to see, did it actually start? These repeated start. If it didn't, you can go into a repeat start. And if that fails to start on the 3rd try, then you will get an alarm in the engine room. You need to be conscious of that. You need to have been watching for that eventuality, so you're already moving and working on the problem. Now, the other thing about this page is it shows you what the main engine shutdown, those things that happen that will cause the main engine to automatically shut down while it's in operation. If the main engine lube oil pressure gets dramatically low, it will shut it off. Same thing with your cam lube oil pressure. Your thrust bearing overheats, or if you have an overspeed. Much more common is slowdowns. The lube oil pressure is dropped below normal, but it is not dropped to a point that it is critically low. So what will happen by slowing the main engine down to full maneuvering speeds, that takes some of the load off the engine, and hopefully your lube oil pressure will come up, and also that you have less forces on the bearings. Same idea with the thrust bearing temperature. Piston oil cooling flow is low. Scavenging air temperatures are too high. The main engine lube oil temperature is too high. Camshaft, piston lube oil temps. Oil mist detector has activated. You'll get a automatic slowdown. Main bearing temperatures. Cylinder lubrication, not enough cylinder lubrication. High exhaust temperatures. Cylinder cooling water outlet temperatures have risen too high. Piston lube oil pressure. Cylinder cooling water pressure is low, and exhaust temp. So all of those would cause a slowdown, and it's important in real life that you understand those. Now, some of the other things too is these are any things that participate in the engine failing or not being able to start. Some of the blocks are on for the starting, those three that we opened. Your start air pressure is too low, it will not try to start. Your control air pressure is too low. Safety air there is a special circuit, a second circuit with its own tank that will supply air to the puncture valves even if you lose the main control air pressure. This will be discussed in class with your instructor. The start too long, in other words, it released the air and it did not pick it up. Repeated starts, which we discussed earlier. Now, the other thing is you've got here load limiting, and the load limiting can be scavenging air limitations and torque. Scavenging air, have your turbochargers spooled up. You don't want to increase the fuel faster than you are supplying an increased volume of air, because that will cause it to burn black. So if the scavenging air pressure until the turbochargers spool up enough, then that will limit the fuel rising. Also, torque limitations. If your torques on your engine are excessive, and that is a limitation on bringing it up even in maneuvering speeds. Thermal monitor is basically above maneuvering speeds. Even though the engine is not limited by torque, it is going to slowly ramp up the power of the main engine, usually from full maneuvering to full C speed about at least 30 minutes. Okay, so, and that's called a lot of times called the ramp up. So let's go look at our indicator panel again. All right, some of the important things to look at here. What we can see, we're doing around 40 RPM. The ship speed now, we're actually going 2 knots in the ahead direction, so we're going the right way. Start air pressure. If this starts getting too low, the captain has used too much air, has been trying to start and stop too often. The other ones that I really like, of course, is fuel oil pressure, but it's specifically fuel oil temperature, 120 degrees and 15 centistokes, right? You want to be watching this with the startup of the engine to make sure the viscosity is staying correct. We are maneuvering out on heavy fuel oil. Scavenging air pressure. We're already above 0.5. We're actually at 0.7 bar, right? So, yeah, what is that? 10, 12 PSI boost. And our turbocharger RPMs are over here on your right, and we're already spooling up to about 4,500 RPM on the turbo, so they're responding well. You should also be looking at keeping an eye on your boiler. That's very important. And looking at your drum level and looking at your steam pressure. Also, you should be watching your diesel generators. You know, the bow thruster, you're still taking the chance that they could be overloaded. Now you notice now that both of these generators now, their load is low, and the turbo generator is picking up the rest. Let's look at our load. Yes, so normally the automation would be taking a generator offline. You can see that these, in fact, that just dropped low enough that I suspect, yep, the old man has secured the bow thruster. He's stopped the motor already, so we can take power off of it. So I'll go to starters and open the bow thruster. That big motor, you only want it engaged when they're actually using the bow thruster. So again, normally this would be shutting a generator off. The load is quite low on those two. And that is the reason we're not taking off the alert mode, is specifically because that is in your standing orders to maintain all three generators on the line. So okay, some of the things that we should be looking at now. Let's go look at your turbocharger system. So we can see here that our turbochargers, the vessel has cleared the harbor breakwater, and you now have clearance to start the evaporator. So let's go get that moving. The reason that you don't want to be making fresh water in port is because these types of evaporators do not get hot enough to kill bacteria, and you usually have quite a bit of bacteria and disease organisms in many harbor waters. So you wait until you're out in the clear ocean water before you start them up. Otherwise, you could charge them up with bacteria. First thing you want to do is make sure and close this drain. Don't forget it. And then you want to open the inlet to the feed pump, its outlet to the evap, and the overboard. And then go ahead and start it. And go ahead and shut this vacuum. It's a vacuum breaker valve. Now, what's going to happen here is always make sure that you do have a good flow. And this is pumping salt water into the evap. That is just going to be a high vacuum, right? The vacuum is high, which we know. That alarm cleared when we started it up. Now, this adductor, in this direction, it is taking pressure here from that feed pump going through the inductor, and that is sucking your brine out and overboard. So this is acting as a brine pump. And then on this adductor on this side, it is taking a suction on the distillate condenser and drawing air out, and that's what's pulling your vacuum down. Now, on this, we still don't have any cooling water or distillate condenser, so we're going to come over here and put on the water to the distillate condenser. This is the most common reason why the students are not successful at making water. They forget this point. You have to have the distillate condensers, what's condensing that vapor into water. All right, the bridge will be slowing down the main engine a few minutes to drop off the vessel pilot, and they're going to be reducing speed. Okay, so we're not going to go any further on this until our vacuum comes down. We want to have the vacuum reduce prior to, and the alarm cleared prior to putting heat on it. So we'll let that go. And let's go look at our indicator panel again. All right, so the ship's doing about 6 knots right now. And let's go to the engine control. And we're doing about 47 RPM. Oh, they just stopped the main engine. All right. Now, one thing I want you to note. Departure will be given in a few minutes, allowing time for the pilot to board the pilot boat. Once the pilot boat is safely away, the bridge will ramp up the main engine to full navigational sea speed. All right. Now, you notice the main engine hasn't stopped. It is still spinning. Right? It's still spinning over its 16 RPM. All right, let's go back to the fresh water. Now, once this vacuum is cleared, we can put on the jacket water from the main engine. Now, one of the things, they've just stopped the main engine though, so there's going to be less heat being produced. And it is interesting to watch your freshwater controls. What you're noticing now is before you were sending water to get back and be cooled. Now it is switching over to almost 100% recirc. You see that? All right. We got an alarms. Cylinder lubrication flow. Well, the main engine probably just stopped. Let's go back and take a look. Yes, the main engine is stopped and not moving, so that would be normal for your cylinder lubrication to stop also. So that's just a false alarm. Now, let's go back to our freshwater generator. So we're actually going to be sucking down the temperature even more because the engine stopped right now. Put on your inlet and outlet to this is the inlet and that's the outlet for jacket water to go through the evaporator. And then on the bypass, drop it down to 25%. Now, why am I not worried about depressing and bringing down severely the main engine jacket water? Because this has a temperature control valve right here, and the Bear does too on its evaporator system, that if the outlet temperature of the main engine is lower than 79 degrees, it will automatically bypass the evaporator. So this is all automatic. I don't really have to worry about it. It sees that this could be depressing the main engine, and it will automatically recirculate the water back. So let's go back and look. All right. So what we're seeing, and you notice now actually on the temperature is starting to come back up again. But anyway, this is in free recirculation, full recirculation, no flow back for cooling. And that recirculation valve, it's almost wide open here too. So most of the water is recirculating, and I don't have to worry about the main engine being subcool or being cooled too severely. It's all automatic. Now we have to wait for water. You want this to be a third to half full before starting up the distillate pump. So we have to wait until this will start making water. And by the way, with the main engine being shut down, that's going to delay it a little bit. But again, it's automatic. Let's go see where we're going. Let's actually go back to process, main control system. Okay, so we are still in the stop. We're still stopped. So I'm going to wait here by main engine control. And we're going to wait for that engine to start back up. So a few things to point out on here. Whoop, we just got in the head bell. So they just got actually a slow bell. The main engine has started. Okay. So at this point, what I'm going to do is on the generator controls, the pilot's away. We're going to get the departure very, very soon. Everything looks normal. Let's go back and look at our freshwater generator. We're still not supplying, and again, the main engine is just started up and it's still running at a fairly low speed, so we'll have to generate a little bit of heat. Let's go look at our ventilation. We're still on a positive on the ventilation, so we're good there. By the way, we will have to keep an eye on this because as this ramps up, that's going to go into the negative, and we'll need to shut down these two exhaust fans as the air pressure. Again, your turbochargers are the biggest exhaust fans that you have in the engine room. And as those spool up, your engine pressure will drop down, and you have to turn off the exhaust fans. So let's see how we're doing. Okay, so we're still at about 4 knots. We're still doing about 32 RPM. We are not being, neither the thermal load manager or the torque limiter is currently on. Some of the things that are good to check too, you do want to check your fuel system, that everything is going well here. You want to be looking at with the engine running, at your lubrication oil system, making sure your temperatures and flows are good. You also want to be looking at your bearing systems, looking at bearing temps. Another very, very important is that you are watching your exhaust temps and making sure that they're fairly similar in temperature, that there's not any big deviation, and they're not up through the alarm point. The alarm point is about 450 degrees C. So we're down in the 200s. So we're good. Let's go back and look at our freshwater generator again. Okay, that they're going to be, we are going to get departure and shift from standby to sea. At sea is departure. So let's go ahead and put this up. We'll go back to main engine control. Okay, so there we've got departure. So at departure now we can start switching over our generators. We're going to go to put the generator control, take it out of alert mode, take all generators out of auto, and the first thing we're going to do is shift power from the turbo generator to diesel generator number 2. So I'm going to bring up the turbo generator on this page. On my second screen, I have diesel generator number 2 up. And to take it off the line, I am going to decrease the governor on the turbo and increase it on the number 2. And you keep doing that in short. Be very careful. You have to double click. It stays in if you're not careful. So you click it in and then out. So you click and click, double click, and you keep transferring back and forth. Now, one of the things you notice here that I'm a little bit high on the frequency, so I may do a couple clicks on this and get it down below, slightly below 60. So you're going up and down right at the hertz mark, and then keep going back and forth. Again, I'm adjusting the governor on number 2 up and the governor on the steam turbine down. And I'm watching my power, and as soon as it gets down around 20k dub, then I'm going to take it off the line. Okay, let's go ahead and disconnect. Now that we've disconnected it, what we're going to do is we're going to go to the steam turbine. And I am going to shut off steam to the turbine. I'm going to open the drain and go ahead to switch to and it's a right click to the oil-fired boiler. And I'm going to go to the oil-fired boiler and I am going to shut the superheated steam stop to it. You notice that the boiler has cycled off. I also like to go to boiler combustion and decrease the set point on the master controller to 6 bar to help prevent it accidentally starting up. We don't want it running at this point. We want it strictly off the waste heat. Then I'm going to go back to the steam turbine, and I have to wait until my superheat temperature is in range, in other words in the green. It is, and I can bring it back up on speed now. And we leave the drain open while we're bringing it up. Make sure that we don't have any water encroachment. We're at about 4,700 RPM. Now, this is not really realistic in how much I can open the governor. I just opened it up 25%. Steam turbines react very, very quickly to load changes, and this would react faster than this. It's the way the simulator responds. So anyway, I've come up, and it's starting to come up now. I'm going to go ahead and hit it at 50. And again, turbines are much more responsive than this. This is it's with the simulator. Okay, we're up almost at 6,400. My governor is shutting down. So I'm going to do it in 2 stages, 75. Oops. 100%. Okay, I'm wide open now. I'm well drained, and I've got 5 minutes to complete. So I'm going to close my drain here. The generator is back up on the line, so we can go ahead and put it back on service. I'm just going to make sure real quick that my oil-fired boiler, the fire is out, and I'm up about 8 bars, so we're doing good. So I'm now going to putting up the turbo generator again, and I'm going to put it back on the line. My second screen still has diesel generator number 2 on it. Go ahead on the turbo generator, hit synchroscope, and this comes up. Put it in for the turbo, the steam turbine generator. Here you have bus and generator frequency. Your generator frequency needs to be above bus, and you should have 2 to 5 volts on the generator higher than bus. Excitation controls voltage. The governor controls speed. Now, if anything, we're going backwards on our synchroscopes, so I'm going to increase this until I am moving in the clockwise direction at a fair rate. And by the way, if your voltage is good and your frequency is good, you get these 2 green lights at the bottom. And at 11%, 11 o'clock, I connect the circuit breaker, and I've locked in, and I'm showing power. Now, go ahead and shut off the synchroscope. We can exit out. Now, I only want to bring this up to, in the beginning, to about 150 kW, because the engine's still coming up to speed, and we don't have lots of steam available. All right. So my distillate condenser, I forgot to go back and check. It is it's overflowing now, so let's do that. Freshwater generator, it's not a big deal. It gets pulled out with the brine. Put your salinity control in auto, and go ahead and put your distillate. At this point too, I'm going to check my ventilation. We're starting to go into a vacuum, so I'm going to shut down both of my exhaust fans. Let's look at main engine control. We're up to about 55 RPM, which is good. And we're up high enough now to put a shaft generator in. So let's finish this up. So I'm going to go back to the turbo generator, and I'm going to bring its power up to about 150. Now this is already a little bit high on the frequency, so right now I'm just going to decrease on number 2 generator. So I'm on my other screen, and I'm decreasing its load, and transferring its load over to the steam turbine. And again, I'm just clicking it. I want it to get slightly below, and then now I will increase the load over here. And I'm going to leave it about that. That's going to be about good. All right. Yeah, maybe a little bit more than I want. So there we go. Now, the next thing I'm going to do is I'm going to bring up on this screen, so you can see it, I'll bring up diesel generator number 2, and then on my other, I'm going to put up number 1. And now what I'm going to be doing is I'm going to be transferring the load off diesel generator number 2 to number 1. All right, so the same process. I'm going to decrease and increase. Decrease number 2, increase on, or excuse me, number 2 and increasing on number 1. Trying to keep it at 60 hertz or close to it. I'll do a double click on this one to bring that up a little bit. There we go, decrease. Same procedure. And we're going to end up with both diesel generators offline with just the steam turbine and the shaft generator on. Disconnect. So number 2 is off the line. So now I'm going to put the shaft generator on. So we'll go to shaft generator. Same thing as before, synchroscope, shaft generator. Let's increase the speed of it slightly. That looks about right to me. So basically what you're doing is you're increasing the speed and the voltage are slightly higher so that it automatically picks up some load. So I'm off. Let's exit. Now I'm going to transfer all of number 1. I'm going to transfer to the shaft generator now. So I'll leave it the way it is. I'm going to increase. Actually, I'm already above 60, so I'm going to decrease number 1. Which will transfer load over to the shaft generator. Okay, now, so I'm just going to increase and decrease, same exact way. Okay, I've got a minute, 29 minutes. Transferred quite a bit of load. Okay, disconnect number 1. I'm going to go back to power. Generator control. Alright, so both generators off. Turbine on, shaft generator on. We want to go priority 1 on the shaft generator. Number 1 is priority 2. Whoops, not 2, 3, sorry. Put all 4 generators, I'm sorry, in auto and put it at optimal mode.